Thanks everyone for the opportunity of being here today to present to you. Just as Paul said, I'm just going to present a project actually we've been working on, which has to do around the energy systems space as well, called Clue. And this addresses the energy systems challenge, more focused on the UK perspective. So just a brief sort of agenda would just be a bit about the UK and where things are going in terms of the energy systems. Then the focus really of this presentation is of local energy communities, and that's where this project Clue, Scott Clue in the Scottish side of the UK actually works on those challenges as well, trying to see how we can progress that in the future. And then lastly, I'll just talk about cross-collaborative work as well. We're working with the other EU research institutions. We're working on this project as well. And one aspect around sort of like organizational concepts and regulatory frameworks and how that affects the progression of local energy systems and local energy communities in the future as well. So slide just gives a perspective of where things are in the UK and where things are moving. So we initially are at a stage where we have probably around 7 gigawatts of offshore wind. Majority of our home systems are still heated through natural gas. We're still moving towards the electric vehicle sort of regime of things, but we still have quite a number of fuel, petrol, diesel-based engines and everything. But in terms of renewable energy, we're vastly increasing the amount of renewable output that goes into the grid, and making things a bit smart with more smarter meters and all as well. So that's where things went in the future. We have different ambitions to sort of hit net zero by 2050 with everyone, and with targets such as 40 gigawatts of offshore wind going into the network as well, and moving from natural gas into hydrogen-based systems, moving to electric-based vehicles, and even having a larger proportion of offshore wind in contributing towards the generation elements as well in the network as well. So the question there is, as we start to move into much larger offshore wind, the challenges become a bit more. And the variability of renewables as well needs to be tackled in terms of storage and other clever concepts. So in terms of our Catapult, we've been involved in 3 projects at the moment, 3 of our projects which has to do around tackling this issue. One is the Milford Haven Energy Kingdom, and that's based on the port of Milford Haven, which is a region in the southwest of the UK, which has a port there and has sort of like more like a very nice use case for having a study of the future energy systems as well. And we're working with different partners in assessing how different elements such as the region in that region could be used to sort of make the energy system a bit smarter, including the offshore wind contribution from the Celtic Sea region in that as well. The other one which I'll be talking about today is the Clue project, and that has to do with local energy communities. And we're working with this with different countries as well, apart from the UK, Germany, Sweden, and Austria. And we're working on tackling the challenges of local energy communities in our respective countries and sharing knowledge between both countries as well, and understanding how we can bridge the gap in understanding as well. The last one, which is the H105, is a very interesting project because that has to do with our key assets we have in the EERA Catapult, which is a level mount demonstration turbine. And we're working with Scottish Gas Networks, when they will be installing an electrolyzer at the wind turbine to prove the concept of green hydrogen being developed from a 7 megawatt turbine. And that will be feeding directly into 300 homes in phase 1 of the project, and anticipated about 1,000 homes in phase 2. And that's the project that's started going on right now, will run up to about 2025 as well. And that will prove not just the concept of green hydrogen, but the concept of having hydrogen boilers in homes and testing that in terms of consumer and customers kind of like benefits as well. So that's an interesting project as well. So main focus today will be on the Grow project, which I was just talking about, and that's based on looking at concepts for planning and demonstration and replication of local energy communities, making them user-friendly. So this project at the moment is between ourselves and a host of companies based in different countries. As I said, UK, Sweden, Austria, and Germany. So you can see a list of companies that are involved as well. On our side, we are working on the Scottish side, the UK side of things, which is Scottish Clue Consortium, which involves ourselves, Rory Catapult, and other two partners, Smarter Grid Solutions and SETWind. And in our case, we're trying to see how to use our assets in terms of improving the knowledge, like our LDT turbine as well. So Scotland project in our case is a demonstration project. Each country has a use case that would demonstrate a local energy community. In our case, we're demonstrating a multi-vector based local energy community. So trying to not just have electricity generation, but look at future gas generation through hydrogen as well in the local energy community. And this is based on the actual local community in 5 regions of UK, which is around the northeastern side of the UK as well, going up to Scotland. And this project, as you can see in this slide, is a combination of 2 aspects. One has to do with each country having its own physical demonstration sites and understanding how they could basically connect in a real life situation, local energy communities, and doing some testing and validation of how those concepts will work based on different sort of use cases. And those are the different work packages 4, 5, 6, and 7. But they're also like cross-collaborative work packages that look at different aspects, such as the regulatory issues, such as how the use cases could sort of merge together to improve the understanding, such as aspect of the different tools each country are using to develop this concept as well. For the Scottish side of things in the UK, aspects is work package 7 and has a broad outline, as you can see, that looks not just into the demonstration, but also stakeholder interactions, understanding how these concepts would be applied and what stakeholders think, especially the community, about having a future of hydrogen/electricity network. And we have stakeholder workshops, which we're doing through an outsourced contracting with the Community Energy Scotland, who's a partner as well, helping us in this project as well. So based on the project, there are basically 3 main partners in Scotland: ourselves, University of SETWind, and Smarter Grid Solutions. So also ourselves, we're the operator and the maintainer of the assets, and we basically using our LDT turbine not just to do monitoring, but also to imbibe elements of control. So we want to see how you can control the assets to switch up the demand under different conditions. SETWind has expertise in cybersecurity and data modeling, and they are the ones involved mostly in terms of the modeling of the different things. And we have an innovative concept we're trying to prove here, which is called a web of cells architecture, which I'll be describing later on. And Smarter Grid Solutions as well, who are the ones that actually bridge it together with the active management system, which is just software that brings it together and creates a cloud-based architecture that can connect all the different assets together within that as well. And as I mentioned as well, we're looking to link this into this 5H100 project, which is the project I mentioned that would have an electrolyzer on site. And we started discussions with Scottish Gas Networks, and they're quite interested in us aligning this project with that project as well, which we're involved in. So that's quite interesting for us, because we also might be able to prove like a whole systems architecture of how things would work in a multi-vector based system. So this is sort of like a diagram we usually use just to describe what the ambitions of the Scottish side of the demonstrator is. So we have what we call different cells. The cells are a group of assets we group based on sort of like the similar features and the regions as well. So in our case, we have the 11-man demonstration turbine as a wind power cell. We also have the community, which we have 2 community centers we're working with, which some already have like PV installations in there, but we're actually going to be installing additional home storage battery solutions there. And we're using like our kit to sort of control as well the energy storage devices, so that we could have controllable assets to see if we can, turn on the demand and supply of them as well. On the other aspect, as I mentioned, the H100 is seeming to be a new cell that will come in today that will be a real life demonstrator of a green hydrogen plant there. But as well with SETWind, we already started development of virtual models of that. which we can switch in at a later point to the real life demonstrator as well for the H100 project. And other aspects which we feel like we cannot physically demonstrate, we have what we call virtual simulated cells, which are based on hardware in the loop infrastructure available at the Strathclyde University, which we kind of put in our active management systems to link up to the wider sort of central controller as well, which you can see on the top, which is a system based on SGS, Citrus Flex platform. And that forms the multi-vector energy systems platform that would decide between gas and electricity, how you basically split the demands in the community as well. All linked together as well is the DSO, which we don't have direct involvement in, but we're using the existing infrastructure, which we have access to see how we can test that as well. So one aspect, as I mentioned, is the sort of like the architecture that controls groups of assets, which is a web of cells architecture, which is something that's been developed in the past from my previous work that Strathclyde University was involved in. And we brought that into this project to see how we can actually implement it on a physical demonstrator and link it actually to a physical local community. So what it is that you group your assets into based on familiarities and interfaces as well. So you could have a wind power cell, you could have a hydrogen-based cell, and those cells are a group of assets, as you can see in there, and even the virtual cells as well. And you test all the different communication elements that need to happen between each cell. But apart from just each cell, we also are interested in understanding cell-to-cell communication, intra-cell communications, and that's the part we were kind of interested in proving as well, that we could also, apart from communicating within a cell, we could also make decisions based on adjacent cells to each other as well. And that's where this smarter grid solutions, A&M structure, we're developing this sort of back-end technology based on cloud-based infrastructure with an algorithm that runs on that as well, that would actually allow this to happen. And that's what University of Strathclyde and Smarter Grid Solutions does in this project. And this is just a sort of like a high-level description of that system from SGS, which basically is just, it could be any based cloud-based platform, but in this case, we're working with the Google cloud-based platform for your base. And the A&M elements are the hardware you actually locate on the individual assets, while the A&M strata you can see on the top are basically just the sort of like Amazon-based, AWS cloud-based structures that bring it all together. And I think for SGS, their prime knowledge here is trying to see how they could start to build a sort of architecture they can also take into their business and do for other future projects as well. So quite tallies with what different interests are as well with the different partners in the project. So that's on the Scottish demonstrator, which has to do with in our case, the UK demonstrator in Scotland. But as well as that, as I mentioned previously, I just wanted to touch a bit on other aspects like we'll be working on, which has to do with cross-collaborative efforts between UK and the different countries. And one thing we recently were looking into is trying to understand organizational concepts or regulatory frameworks that allow local energy communities to actually come into play. So I think in the previous presentations at the start, there was talk about renewable energy directives, which sort of states out this framework for local energy communities in EU. But in respect to the UK, one thing is that because of the sort of the relationship of the UK with the EU, when we've not really been aligned directly to those directives as well, and only like Northern Ireland at the moment. Based on the recent developments with Brexit and based on the withdrawal agreement at the moment, only Northern Ireland and the region between Ireland as well sort of have some broad context of how that sort of relationship might work in terms of conforming to EU directives. So from our side, there are a number of documents which are the trade agreements, withdrawal agreements, and nuclear cooperation agreements as well, which sort of outlines some sort of clauses there. But the key thing here is that these are not still yet clearly defined. We're still quite the early times of understanding what the future energy relationship would be. So so far with the UK, we're not from the start obliged to follow these directives, but we do see that there was certain elements of the internal energy market that might come into play based on this region between Northern Ireland and EU. So compared to the actual renewable energy, the dynamics has focused to renewable energy communities in EU. They are the renewable energy communities and citizens energy communities, and certain sort of clauses there that sort of give that high level definition of how you want to enable the consumers and the communities to start to engage directly in terms of the usage of their generation and their demand as well. But in terms of UK, as I said, we're now obliged to follow that, and we do this in a very different approach. So local energy communities are done from a UK regional perspective at the moment, which is Community Energy Scotland, Community Energy England, Wales, and Northern Ireland. So this has to do with the 4 regions within the UK. And as you could think about it, each region would have certain sort of slight changes to their approach. But the main sort of legal framework that brings it all together is the UK Electricity Act, which basically gives the rules and of how you license generators, supply and distribution, and they all have to conform with the actual UK grid code as well. So I just want to discuss briefly some barriers and trying to look at both sides, which is some of the work we did, just to understand UK perspective to EU perspective. So, and the barriers we see is that the current policy at the moment in the UK only enables local generation, but not local supply. What that means is that the UK sort of rules are outdated, because this was built on a framework of how the energy system was privatized back then in 1989 in the UK Electricity Act. So you basically, by law, energy flowing through the grid can only be sold to an end user by a licensed supply company. So you're not allowed to basically sell energy between local communities or between customers. And until sort of like that sort of law is sort of amended, which is sort of in the works of it happening, but not yet done in the parliament, that's still a major barrier as well. So most of our sort of revenue models are based on, in the past, feed-in tariffs as well. And that's how this sort of renewable energy projects are being developed. So it makes no provision for local energy supply by small scale or regional suppliers or multiple suppliers through 1 meter. So and that's sort of the thing that needs to change to make things better. As well, incentivizing local supply. In the past, we had feed-in tariffs, which was helpful and did make a business case for most of these projects, but that's been scrapped and moved into a new scheme known as a Smart Export Guarantee. And sort of the revenue mechanisms that people would use in the past to sort of work on local energy communities are now in doubt, because in the past you were being paid a fixed price for exporting your electricity and a fixed price for generating, which were based on assumptions. But now it's being moved to this new mechanism where there's variability, and it's almost like it's like going into like how you sell electricity with normal gas suppliers or electricity-based suppliers. So the tariffs are set by the companies now, not by the governments, and that puts that sort of like revenue mechanisms in risk as well. So those are the 2 main sort of barriers, but there are still some other ones. But some of the things we're looking at as recommendations as well. And we thought new actors could be coming to play. So like the way things are done in EU directives, it sort of gives a nice framework of how each country would interact and help to sort of progress and transpose those laws into their respective countries. So it would be nice to have a UK sort of wide national local energy community body that sort of bridges those different regions together and align their interests and align it to sort of similar clauses in the EERA directives that the UK could be working on. Community aggregators as well could help. What that means is that your community could actually be in charge of how you supplier and control the supply and demand of the energy within their community. It can also be extended to existing actors as well, with their roles could be extended. Technology aggregators at the moment could also start looking to having communities as groups of assets. The DSO as well would increase flexibility. Ofgem as well, which is the regulatory body here, could also extend a bit more on their guidance. And as well, the UK government could update legislation as well to progress things a bit forward and allow for this local generation and supply, which will enable LEC communities. So that's sort of like my presentation. Thank you, everyone.
Thank you very much, John.
Okay, thanks, John. Thanks, John.
So, Nikos, we don't have any online questions at the moment. Maybe we've got time for a very quick question in Amsterdam, if there is one.
Don't see any raised hands here, but I was a bit curious. Maybe that's because of my ignorance. If there an estimate how much of the total market, could be or supply or demand of electricity could be covered by these local energy communities, which in indirect supply, not through the TSO or other other big utilities.
So I think I won't think it's going to be a huge proportion, but probably some percentage of that could be in terms of how that would work in the future. And that would probably rely on, grouping of assets within communities. And I think the aggregators would have a big role to play there. It's just similar to what is seen in the UK with different aggregators, like where batteries are combined together. So it'd be good to see, how you monitor sort of the generation in each household. You can combine them cumulative as a total sort of net generation capacity and use that to play in different markets. So on that sort of scale would be similar to probably the scales of how aggregation is getting to. And that could form as part of their sort of like assets combinations that could be in the play with aggregators. But in terms of direct relationships to a degree, that might be a bit more difficult because most of these would be generating at lower power scales and wouldn't, unless you have big assets, but that would classify as sort of like community-based asset if it's quite big, maybe about 10 megawatts or above. So,
and John, I know the project's also looking at scalability, isn't it?
yes.
Whether some of these LEC techniques can be used on a regional, national basis. So maybe that would up the percentage, so to speak.
Yes, so future work is actually going to be looking into, as Paul said, scalability as well, understanding how you can scale this up to national level.
Okay. Yes, great. Then I would say thank you again to John.